Hey guys, welcome to a new lesson. We're hitting the second chapter. I accidentally put unit. It's still unit one, but we're in chapter two, and this is the first lesson. And if you kind of take a peek ahead, we're just going to be solving equations today, so pretty easy. One of the things that I see students make a mistake on is really knowing the difference between an expression and an equation. So obviously, like an equation will have an equal sign, and an expression does not. The way you attack these two things are completely different. So for an equation or for an expression, you're going to combine like terms. That's your goal. And remember how we talked about the house and the order of operations? Well, so this one, we're going to follow order of operations. We're going to go down. So please excuse my dear Aunt Sally. But if you're solving an equation, so let's pretend like 2x plus 1 equals 3. The first thing you would do is you're actually going to work up on that PEMDAS house. So we're going to get rid of addition and subtraction first, and then we're going to handle multiplication, division, and then if there's more, we'll deal with that as well. So these are kind of, when you're solving them or going through each problem, they're going to feel a little bit backwards. So I think the best thing to do is just, why don't you take some time and go through these 6 problems and see what you can do and can't do, and then I'll work them out and we'll kind of compare answers. Okay, so there's a lot going on here, and I tried to show my work the best I could as I was going through here. So on a lot of these, we're having the distributive property, and so that was what was going on here. Other than that, number 1 is pretty straightforward. You can just see my work. On number 2, anytime you have a fraction, there are several different ways to do this. The way that I choose is I find the GCF of 8, 4, and 2. Sorry, not the GCF, the LCM of 8, 4, and 2. So the least common multiple. So what is the lowest number that 8, 4, and 2 will all go into? And so 8 goes into 8. 8 goes into 4, and 8 goes into 2. So my LCM is 8. So once I figure that out, what I'm going to do is I'm going to multiply, let me see if I can clean this up a little bit. I'm going to multiply this whole thing by 8. And what I like to show in my work is how I do it to each term here. So I multiplied 8 times 3 eighths, and notice those 8s cancel out, and I'm left with a 3. So that's where that 3x is coming from. 8 goes into 4, 8 divided by 4 is 2, and so I'm going to have a 2 left over. So 3 times 2 is 6. That's where that 6 is coming from. 8 divided by 2 is 4, so there's going to be a 4 left over. So 5 times 4 is 20, and that's where that 20 comes from. Now it becomes a pretty simple equation, but this is definitely the most difficult part. So if you need more help on that, just let me know and I can help you. Number 3, I guess the most difficult part about this is just dealing with the yucky numbers. So we have like 0.02 that we're going to distribute. So 0.02 times 100 is 2, and then we're dividing by 0.08. Other than that, that one's pretty straightforward as well. Number 4 is very similar to number 2. So we have the numbers 4, 2, 3, and 6 on the bottom. So our LCM is going to be 12 because 4 goes into 12, 2 goes into 12, 3 goes into 12, and 6 goes into 12. And so I did the same. I don't know if you can see it very clearly, but I multiplied 12 to each one of these terms. So 12 divided by 4 is 3. 12 divided by 2 is 6. So I multiplied that 6 times whatever I had up here. 12 divided by 3 is 4. That's where that's coming from. And 12 divided by 6 is 2. That's where that 2 is coming from. And then I kept whatever, I kind of looked at it as parentheses. And so that's how I got that line. And the rest, I believe, is just distributive property. It's pretty straightforward. This one, like the process is really similar, except when you get down here and nothing makes sense. So if I had -3 equals 7, that does not make sense. So in that case, whenever you come up with a situation like that, your answer is going to be no solution. No number that you put in for x is going to work. Number 6 is kind of the opposite. So we get down, and right here, it makes sense. So we have 0 equals 0. It doesn't have to be 0. Be 5x equals 5x or -3 equals -3 or whatever. If it makes sense, then your answer is infinitely many solutions. Anything that I plug in for x is going to work. And I believe that we've covered everything for solving linear equations. So if you have any questions, let me know. Thanks.